Greetings, sentient being, and welcome back to Punkworks. I'm Pluto. Or, wait, no. Welcome back to Pluto, and I'm Punkworks, or something. I actually don't really know. I don't give a fuck. So, welcome back, and this is going to be another slightly educational video regarding the game Greyhack, which is a game that simulates hacking better than any other game on the market, but just remember it's not real hacking. If you want real hacking, go do like Hack the Box or something, or try Hack Me, like real shit. This is a game, okay? This is more accessible to people that just want to play a game and don't really want to actually go back to school. Anyway, so what we're going to do today is a quick recap of the meta exploit lib and the meta lib, and we're going to discuss how the meta command in my program shell works, and we're going to discuss, remember shell, that's my dealio right here, and we're going to discuss how to basically do your own meta command. If you take a look here, you can see meta help in shell is a bit large. Okay, so we're going to go through and I'm going to show you how to do each of these steps, because shell breaks down every step into little pieces, and then you put all the pieces together to get done what you want to do. Okay, so I'm going to show you how to do all of this. Okay, so you don't have to worry about, no, I'm going to show you how to do it. Okay, all right, I will teach you by the numbers. And here we go. Right here. First things we're going to do is I'm going to show you how... Oh, actually, here, let me get my cards up. Right. I had it up a second ago, and I cleared it off the screen. All right, so you notice here we have meta exploit lib, meta lib, and net session. Okay, and that's what we're going to discuss today. Meta exploit lib, meta lib, net session. These are the functions associated with those three APIs, as basically was what they are. So meta exploit, you use include lib, and then you tell it where meta exploit is, and it includes the meta exploit lib object that gives you access to these functions. Now, this function here, load, is what you use to get a meta lib, which is down here. You use overflow. This is basically what you're going to use right here. Overflow, using a memory address and an unsecure value and an optional, inject value to do your hacking. It's the backbone of the hacking in the game. There are other ways to hack in the game, but this is the, I guess, most important way. So you get yourself meta exploit. It gives you a meta lib. Now this is for a local library in your lib folder. There are a whole bunch of them in there. I will show you that there are a number of libraries that you can find, and these aren't all of them. You can find more. Okay, there are a number of them in the lib folder. Now, if you want a remote target, like say you want to attack, someone's network, you're going to need a port number and an IP address. And right now, I'm using my router. And routers are port 0, and that's going to be an integer, by the way. String for the IP address, integer for the port, and port 0 is the router. Now if I wanted to attack this secure shell server right here, all I would have to do is change that to 22, and then that to a 2, so that so it points at this machine instead. But we're not going to do that. We're going to do the router. And when you get a net session using meta exploit net use, net use, it gives you a net session. Then once you do that, you get dump lib here. Net session, dump lib, gives you a meta lib object. Now I only named them differently so I can tell them apart, but a meta lib from here and a meta lib from here always gives you the same kind of meta lib. By the way, ignore these two lines. I'm on the development version of the game. These will be in the game probably maybe some months after this video is uploaded. So for right now, just concern yourself with these three, and if you're in the future, then we'll talk about these later. So once you've got that, the things we need to do is scan the meta lib. Remember, the meta lib is what gets scanned. The meta exploit lib does the scanning. Here's our scan function right here. We feed that the meta lib, it gives us a vulnerability string, which we then use to fill this out. Okay, so that's going to give us a string. Now, before we move on, we're going to want to print that so we can see what the heck it looks like. And then, once we're done with that, we're going to move on, and then we're going to do the exact same thing to the remote library. So let's go ahead and do that, and we're going to call it rect. Get wrecked. Okay, so we have rect. Let me go ahead and exit out of here. Let's go ahead and we run it. First thing it's going to do is it comes down here, and this is where it's doing the scan. And this is where my dyslexia comes. Vulnerabilities. Oops. There. Sorry, guys. That's just how I roll. Okay, let's try that again. Okay, so that gives us that memory address. The next one we do. One side of my brain is just sometimes it doesn't talk to the other side. And they just kind of both want to do something and like don't really know who's in control at any time, so I just kind of sit back and watch. It's pretty fun. As in, it's not fun at all. Anyway, that finally worked. Okay, so we have two memory addresses for two different metalibs. This memory address will not work on this metalib. This memory address will not work on this metalib. Okay? Different. So, now that we have this, the next step is scan address. So what we're going to do, once we scan this, we're going to do we'll call it scanned data. How about that? Okay, so meta exploit.scan address. We're going to reuse our metalib. Okay, so toss that on in there, but this time we pass it the memory value that we have here. Okay, and of course that's got to be a string. Okay, and once we do that, we're going to go ahead and have it print out that value as well. We're then going to do a similar step. Let's grab it from right there. Copy. We're just going to reuse the variable since we're going to exit here. Okay, so we got remote metalib, and then we got a comma. We're going to grab that value right there. Okay, and then we're going to print that again. Print scan data. Hang on, so you can see it. Okay, so far so good, right? Meta exploit, metalib, net sessions. We're going to scan, and then we're going to get the information out of that scan. Let's rebuild, and we shall run it again. Okay, now as you can see, we have some more information. So this is our first scan. That's that value again. There we go, right there. And the information that spit out is right there. So decompiling source, unsecured values, and then this is an exploit, unsafe check. This is an exploit, unsafe check. This is an exploit, and this is an exploit. So we got 4 different exploits out of that, and you'll notice there's some bold strings here, and these are the unsecure values. And the memory address is, again, that same one. So if there are multiple memory addresses on this, each memory address would have its own set of strings. Okay? And each of these vulnerabilities has a particular set of requirements before it'll work. Like if my machine had, or if the machine in question had had 2 user groups, and this one requires 1, I don't think it means at least 1. I think it means exactly 1. I could be wrong. Well, we'd have to run it to find out. As far as what these return, like what you're going to get from each of these, you do not know until you run the overflow exploit. And remember, that goes here, and then one of these bold ones goes there. Okay, so next step we're gonna do something with one of these. Oh yeah, almost forgot. Also, we have the net session, and as you can see here, none of these have any requirements. All of these should simply work when you send it. But I mean, we don't know until we send it, so we're gonna figure that out. Right. So you may notice we've made a few changes to our initial program. We're going to make it a little more useful. So the first thing we're going to do is make sure it can take some launch parameters so that we're not recompiling the program every time and manually inputting the values. We want to make a more general kind of tool. Okay? So we're going to have it take 2 launch parameters, and I just realized that I kind of messed up. All right, so if it's like that, then we're going to go ahead and accept the input. And we're going to go over here, if is valid IP, then go over here, if dot length is less than 2, we're going to exit as well. Okay, so that just means you're okay. So what we're going to do, if it's a path, we're going to get a local metalib at whatever path we decided to input, and if it's not valid, then we're going to exit. If we input an IP and a port, then it's going to make sure we inputted a port, and it's going to give us a net session object, as we discussed before, using the information that we gave it. Okay? Now, if we gave it invalid input, once again, it's going to exit. Otherwise, it's going to give us a metalib. Either way, we're getting a metalib. And then we're going to get the list of addresses from it, and then we're going to scan those addresses, and we're going to get we're going to print the scan data. So we're going to get a remote metalib from the router in our example. However, I kind of made a mistake. I need to make sure that we're using dynamic addresses. So we're going to scan the addresses, and then we're going to just use the first one that we get, since we kind of know ahead of time that there's only going to be one in there. So we're going to go ahead and build that, do that, then we're going to launch it, fire away. It's going to go ahead and scan, and then there we go. Okay, so once again, unsave check, unsave check. So what we want this, and in order to get that, we kind of need to take a better look at what something like that looks like. So I'm just going to go ahead and, so we don't have to write an entirely new program, I'm just going to kind of show you what it looks like, then we're going to write the program. Okay, so what we just showed you, I'm going to show you using the commands in shell. So again, if we take a look at the meta command, we're going to go up here, and we're going to just kind of start at the top. Gives you a brief overview of what I'm kind of talking about here, and then we're going to go straight to load. Okay, that's for a local metalib. We don't actually want that. We want remote. So link. If you're going to use meta link, it's going to, you can give it an IP and a port. If you don't, it'll prompt you for it, or it'll use the IP and port that you set with target or probe. So we're going to do that real quick. We have now a target set. You can see that's our target. And if I do meta link, it links the metalib right there. Kernel router, kernel router. Okay, now I don't have a database entry for that yet. So what I would do next is this step right here. I would scan it. And in shell, it's basically the same. Here we have meta exploit and scan. It uses the metalib, and we've already got a metalib linked, so we do meta scan. And this will scan the library, and it'll spit out the addresses and then the unsecure values. Now, if we go back up here, that's kind of what we got here. We have the address, and then we have the unsecure values. Okay? So I'm going to show you how to do that. Oh, really quick, I'm just if we were to do meta load, you can just do meta load by itself, and it will bring up a menu, and it'll link that up. You can also do, the library directly with load. And if you're wondering what's in the lib folder, you can do lib, or you can just do ls-lib. Either way, lib will turn green if you have something database, and I will show you what that looks like real quick. But remember we discussed db in the last video, kind of out of order, but don't worry about it. Now that it's been scanned, we know that it's that. So the next time I link that up, that's actually, yeah, sorry, meta load. I keep forgetting. Sorry. Since it's in the database, it loads it up automatically. Now, all that's being said, that's not what we want. What we want to get to this point. So let's do that next. First thing we're going to do is we're going to want to know what that data really looks like. Printing it out is one thing, but we kind of want to know what it actually looks like. So say we were down here, we got the scan data. After we've done all this, we've got this scan data in memory. If we wanted to put it to a file, we could do, we could take that scan data, whatever it says in there, we get ourselves a computer object with get shell.hostComputer. That returns a computer object. We use that computer object's API, remember, APIs, to use the touch function, which requires a path and a file name. So we do that. We give it its parent folder path, and then we give it its file name. And then we grab that file. See, this just makes the file. Then we have to actually get the file object itself so we can manipulate the file. And then we use the computer object and its file function to grab that file. And if it's not there, it doesn't exist, you messed up. Okay, now once you have the file, if you want to set its contents, you use the setContent function, which, if we go down here, right, where'd it go? Oh, right, it's a file function. So we go here, file. If it's a text file, it'll let you do it. If it's a binary file, obviously you can't. But set content and then whatever string you got, and the scan data is the string. So file.setContent is all you got to do. And then print file.getContent if you want to see what's in the file. Set, get, pretty easy, right? Yeah, okay. So that's that. Right, so putting this into our main script and also fixing the typo that I had down there, we're going to go ahead and recompile. I'm going to just go ahead and clear this so we can see what we're doing. And it's going to be 192, we're going to do 192.168.0.1 and then 0. Okay, so it's going to scan, and then this time what we did was instead of printing it, we put it into a file and then printed the file contents. Let me see if I can, what did I name it? I named it file name. That's awesome. Oh, okay, I should probably have renamed that, like actually put, but it's okay. Touch will recursively create folders for you. And anyway, so that's where it put it, and this is the information that it found. So unsafe check, yada 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 yada. Okay, but here's the thing: we can't really see what that really looks like. So we're gonna go ahead and code editor, and then we're gonna go folder. Okay. Now, as you can see, what it actually is bold tags. Right here on each line we have bold tags. Pretty cool, right? So the easiest way to do that is to split or slice. I prefer, in this instance, slice. Slicey dicey. Okay, so as you can see, we got the bold tag, and then we have the anti-bold tag, the open and close. So what we want is we want to slice from here to there, and we want to ignore everything else on that line. Okay, so slice can be used one of two ways. You can use it as a function call, slice, and then you give it a string, an index to start, and an index to finish. Or you can call slice another way. That's pretty much how I always do it. And it's basically you give it the string, whatever your string is, and then you give it the start index and a colon, and then you give it the end index. Okay, and in this case, since I'm referencing the index of a colon in the string itself, okay, it's going to give me the index of that character right there to start, and it's going to give me, let's see, oh yeah, I want +1. Yeah, I want +1 on that, because I don't want it to include that. I want it to give me this without the colon. So it's going to start me off here on this character, and then it's going to go up to this character, but it's not going to include that. This will not be included, so it's going to give me from there to there. If I didn't have that +1, it would give me from there to there, but we have the +1, so it's string go. That's going to be the output. So let's go ahead and build that real quick. Oops. We'll just call it my program. Alright, so we run. Where did I put that on the wrong machine. That's way over here. Alright, anyway, I'll just run it, my program. And it doesn't like the fact that I didn't actually define that. So let's pretend like we know what we're doing. Ended. You guys, one day Lexdexia for cure found will be. You see that? I looked directly at it and corrected the thing that didn't. Yeah, it's fun, guys. It's super. Okay, stringo. Boom. That's what we expected. So, okay, you get it? All right. So let's get rid of that, and let's get rid of that. Let's pop that back up, and let's look at what we have over here for what we're doing. We want each of these lines. So, addresses. Okay, it scans it in. And then what we're going to do is we're just going to take the first one out of that list. We're going to come back to this later because we actually want to loop through all of them. We don't just want the first one. And then from that address, we're going to do the scan address, and then we're going to split. We're going to split that string that we get at unsafe check. If you recall, the data that gets spit out, and I actually think I forgot which file I saved that in. Let me see if I can. Oh yeah, it's in scan cat scan. Okay, so that string that we get, decompiling source, searching unsecure values, yada yada yada, unsafe check is in there somewhere. I forget. But anyway, we do it by the unsafe check tag. And then that's going to give us the string that we saw here. Okay. Oh yeah, there we go. Unsafe check. So each unsafe check is a vulnerability. So the scanned data that we get is going to be split into these lines. Okay. Each one's going to be one of those bad boys. Okay. And we're going to go through. And we're going to store that information, and what we want is a map, and it's going to contain some stuff. Okay, so it's going to contain a list with stuff, and each index of the map is going to be an address. Okay, I go through our scan data, which is a list, and each line in that scan data, if it's the first one, we're going to skip it because it's a blank line. We don't want that. The second line and on, we're going to look for this, and if it's, we're going to scan up to that. Okay, so we're going to skip that line, and then we're going to do this. Okay, and we're going to get up to here, and we're going to grab that, and then once we get that value, as you can see, it's +3, so it's 1, 2, 3. And we're starting there. Okay, because this starts here, and we count up, and then it starts there. So once we get that, we're going to push it to this list. Okay, and then once we've done that, we're going to print it. Cool, right? All right, let's see what that looks like. clear that out. Let's go ahead and exit out. Brains talk. Okay, so let's just do the one we did before, 192.168.0.1. Okay, we scan, and the scan gives us some stuff, and I put a little separator in there so you guys can see what's up. Alright, so each one gives us that. Okay, and then once we go through all that data, we push it into the map. So the map has this as its index, and then the contents of that index is a list, and each item in the list is one of those unsecure values. Okay, so we can save that action for later. But there's a thing. A library can have more than one of these addresses to be scanned. If we were to scan, for instance, let's see, net.so, no, sorry, live net.so. Oh, right, yeah, well, we forgot to do that. Let me print addresses. Okay, so we do that. We run think McFly. Okay. Right. So if we look up here from where we ran it, you can see the list of addresses. There's 4 of them. Okay, and we only got the first one, and that's what's in the first one. As you can see, D, D, we got all those, but we don't have entries for these, so we're going to need another loop. So what we need is we need to loop through the addresses. Okay, so what we're going to do is make a little loop for, oh yeah, right, we need to actually move this from here, and we're just going to go ahead and, well, actually no, we'll keep that in so we can see all of our debugging input. Then we get our scan data. Okay, now right there where we say the other loop goes, so we're going to do for add in. Actually, here's what we're going to do. Here's what we're going to do. Since the scan data is that and the addresses are there, what we actually need is the list start up here. Okay, a little more rearranging. We're going to start our list up here, or our map up here, and then we'll fill it out later. We're going to get our addresses as usual, and we're going to print them out. Okay, and then once we do that, we're going to loop through those addresses. Each address, we're going to scan that address. Remember, meta-live address, and then we're going to split it at the unsafe check, as we have done before. Each of those exploits, our exploits map is going to contain an index for each of those addresses. Okay, before we just had the one, now we're going to make a new index for each address that we encounter. Okay, and that of course is going to be a list, and we're going to go ahead and go through that scan data that we got from here. Okay, each of those, and for each line that corresponds to that memory address, we're going to grab an exploit. If it's the first one, again, we're going to skip. We're going to grab that exploit as we did before, and we're going to push it to that memory area, just as we did before. We're just going to do that for each of those addresses. Now, once we get those, I want to print them out, and that's going to be a map, so it's going to be a little difficult to read. So what I'm actually going to do is I'm going to loop through those, and I'm going to actually print the indexes along with what the index contains. Okay, so you see exploits key. Okay, so you'll see what that looks like. And then once we do all that, I want you to see how we would reference something in that map that we're going to print out. We're going to basically print the very first address and very first exploit unsecure value in that address. Okay, so let's go ahead and get that taken care of. This time we're going to do we're going to do livenet.so again. That way we can see, what that looks like after we've done this extra stuff. Okay, so now you can see if we start up here at the top, those are all the memory addresses we need to scan. And then when we scan them, these are all the entries. And then we put them in a map, and each address has its corresponding unsecure values. And you can see there are 4 addresses, and each of them has a different number of unsecure values. Okay? And then it says down here line, and that is because 0, 0. So exploits, and then the addresses. So addresses, remember, is that scan. It's a list. So index 0 of that address list is going to be that right there, and that corresponds to a key in the exploits map, which is once again that right there. And the contents of the exploit map is this whole list, and the 0th or first element of that list is line. And so that is how you would select a particular, value out of there. The next step, of course, is actually selecting and firing that attack, because so far all we've done is scan. We haven't actually done an exploit yet, so that'll be what we do next. In order to get the attack that we want to send and all that good stuff, we're going to probably put together a menu. And by probably, I mean definitely. We're going to put together a menu. So all this is going to remain the same. This all looks familiar to you, I'm sure. Down here, just a little thing added in. Remember that we can pass a third parameter there for an inject value if we wanted to. Okay. We're just going to make a little memory placeholder. And we'll come back to this in a minute, and we're going to make a placeholder for our function that we're going to use to fire our attack, and you'll probably recognize this right here from when we printed our stuff from the last time. So what we're going to do here is go ahead and print another little divider. We're going to put together a menu that's going to be, each of our indexes of exploit addresses. We're going to print it out, number them 0 through whatever. And then we're going to put that menu together and print it, and the user's going to select something, or it's going to select all. And depending on what is selected, it will send that exploit, or send that value to our function. If something will happen with it, and then we're going to put that together here in a minute. But then once it does that, it's going to put the thing that it gets in memory, and it's going to print that out, and then from there we would do something to handle that object that we get. So let's see what this looks like before we do anything else. So let's go ahead and just orient ourselves. Remember, we've already done all this. We're going to throw that in there. And then from here, you're going to kind of ignore most of this. We don't need any of this. Just don't worry about it too much. But this part, that's just going to be our menu. So you can go ahead and throw this in from here. There you go. I'll let you look at that for a second. Okay, then we're going to go ahead and build it. And remember, this is the last part if you want to throw that in there. Okay. Obviously, you have the ability to pause the videos. Okay, so let's go ahead and do our thing. And it gives us a nice little menu. So it prints out all the volts, and then it's 0 or 1 or A. And then let's just pretend, it's finished, and I say 1, and then it prints it. It's gonna, we're gonna put another menu in here where it prints out the different, values, and then you select one, and it sends it. And then it prints the result. Okay, let's review our code. Remember, we didn't really do anything here, and we're gonna fill this here out in a minute, but this right here corresponds to that right there that you see. Okay, so we come down here, we put our menu together, and each menu index is a line that we print. Let's kind of stretch that out. You can see that a little bit better. Is how it actually looks. Okay. Then from there we select something, and then it does something. So here, user selection. If it's A, if it's a number, then it sends that. Either way, it calls that function and does something. And then when it's done, it returns and comes down here. Cool. So the next thing we're going to do is we're going to fill out our function so that it can actually be functional. And of course, I've already done it, because you know how my brain works. If I tried to just type it out here for you, it would be here forever. This actually took me forever. Okay, now let's put together our fancy little function. First things first, if the input is a list, we're going to handle it one way, and if it's a map, then we're going to handle it a different way. Remember down here, we're either sending in a map or we're sending it a entry from the map, which is going to be a list. Okay. So if it's a list that we send, then we need to select one of these bad boys out of there to fire, or all of them. One or more, actually, is what we're going to do. So what we're going to do is we're going to prepare to store all of those in a payload, one or more attacks that we're going to send, if we're not sending all of them at once. If the input's a list, then for every entry in the list, we're going to print out, the index, and we're going to print out the thing, whatever it is. We're doing this right here. Once we do that, we're going to get the user's, input. So first thing, we're going to take the selection and instantiate it to nothing. And then while that's going on, remember we're still inside of that if statement. Okay. Now while that's going on, while it's not F, which means fire, we're going to fire it with F. The user selection, we're going to get user input, select a value, and then use F. It doesn't have to be capital, but just F to fire. And then it's going to take the payload and push to that payload the selection that we made. Okay, and it's going to be from that list. It's going to be the index that we put in. And if it's not a number or one index, it's going to be like you didn't do it right. It's going to just go back to the menu. And then it's going to print our payload. And what we've got, when we're satisfied, we press fire, and it goes to the next step, which is going to be another loop. Okay, throw that right there. And for each value in the payload, for everything that we put in the payload, each time we're going to fire. Okay, we're going to use the overflow. Remember, that finally came into play. The overflow is how we send the attack against a particular meta-lib. Okay, so the exploits that we're going to send, it's going to be, remember we have our exploits map, and it's going to be the index of input, and it's going to be the value and the inject value from what we've got. Now, if this part here confuses you, let's break it down. We have our exploits map, and it has indexes that are memory values that we've scanned out of it. It's these things. Okay, each one of these is an index, and the index of the input, which is a list that we sent, is going to be, so it's going to be saying the index of this or the index of that, which is going to be one of these. So that's going to be a memory value, which is what we put in for these things. Remember, let's take a look at the function. Oops, let's get a meta-lib first. Let's go ahead and break that down. Remember the overflow that we have, it takes a memory address, an unsecure value, and then, that extra argument. So you put those in there, you put the memory address, and then the value that we select, or each of one of each of the values, and then that inject value up here, and it's going to fire. And if it gets a result, like if there is a result, and it's not equal to 1, because you can't really do anything with the number, then it's going to push it to our memory. Remember, that's up here. Memory is like our buffer. It's where we store stuff. So in shell, I actually call it the buffer. It's the buffer. It's where we store stuff. And then here we're just going to call it memory. And so once we've done all of our attacks, we're going to show what we got. Okay. Once we've gone through all of those, it's gonna print them. We're not quite done yet because we have another condition. So if we've got something else going on, which is it's not a list, it means it's going to be a map. So if it's not a map, then something went wrong. So we're just gonna bounce on out of there. Okay. So it should be a map since we know what's going on. Now, what we're going to do if it is a map is we're going to fire everything. So we don't have to print a menu, it's just going to do it automatically. So let's go ahead and copy this over, and let's break this down. So once we copy this over, what we're going to do is for each mem in input.indexes, and what this is a mem. Each index is one of these, so we're just going to call this a mem, and that's a mem. Take one of these, and for val in input at index mem, which is the input is the map that we just received, and the index is this, which means the value is a list. Okay. For every value in that list, we're going to say that's the unsecure value that we're using. We're going to print it out, and we're going to do the same thing as up here. Result equals metalib overflow mem val, and then inject from up here. Okay, so mem val inject, mem val inject. So every memory is going to have a number of these. So it's going to do this, and then a bunch of these, and the next this, and then the next bunch of these, and it's going to fire everything we got. Okay, it's going to take all those results, and if they're substantial, it's going to put them in memory, which we are then going to print out down here. Okay, and then did I get everything? Oh yeah. We put at the end of our if statement because we're done with that. Okay. Okay. So that's our if statement. Go ahead and take that in, and then it's the end of the function, so we have to do something. So if there's if there is a return value, as in we got something in memory, then they got wrecked, and that's what we return. It's just a string. Otherwise, we return that we got wrecked. And it's gonna. Oh yeah, I should probably. Yeah, let's go ahead and make sure that that actually prints, huh? There we go. We'll print the return. Otherwise, that won't print. Okay, so quick review. We know what's going on here. We're getting all the values and the addresses. And then we're going to print a list. Sorry if I'm moving around too much. We're going to print that list. And then we're going to fire this function. And then once it's done, we're going to print our results. Okay. Okay, so let's go ahead and build this. And we will, oops, let's go ahead and exit out of here, clear that out of the way. And survey says, we get our list, we're going to select 1. And then here we go, we've got our little list, we're going to select that one. See, now our payload is that, we're going to select 3, and now we have that. And if we want to select 3 again, since I didn't put any sort of error checking for that, it's just going to do it again, so you kind of have to be your own whatever. Anyway, we're going to fire with F. And of the attacks that we sent, we have success, obtain privileges from user Pluto, executing payload, password modified, and then we've got, let's see, it looks like we got a file object, and yeah, if we, once from there we have to do something with that file object. Okay, so let's go ahead and let's do that again, but we're going to choose to fire all of them at once. And with this, we had a lot more successes, as you can see. I fired everything. And, that one failed because there's no guest user, that sort of thing. I didn't really print a whole lot of what we got, so there's definitely more information that we could add to this to make it clearer what's going on. But this is just kind of down and dirty what we're doing. But we got a number of objects, 3 file objects and a computer object, which would allow us to do a number of things where we could take steps to escalate our privileges. Really quick, I'll show you kind of what that might look like in shell. And so I'm just going to go and do a quick kind of skip all the extra parts, and you can see same thing, guest computer, guest file, and the rest of them, no guest user found, the exact same thing. Okay, password change right there. And then if I were to look at my holdings, you've got a file object here. You could do something where you've got a number of different things, but most importantly, like a file browser. You can take one file object and get the entire rest of the file tree, whether you have read permission or not, and you can see what's going on in here. Just kind of go through their whole directory and see what they've got. And if you've got permissions, you can obviously manipulate it. If you get a computer object, there are a number of things you can do. See the processes they're running, mess with their Wi-Fi, for instance. You can see their Wi-Fi networks in range. But most importantly, you can tree their home directory, and if they have them, you can get their mail and bank credentials. Let's see what that looks like against a target. So we got a random target here. I'm gonna go ahead and just go ahead and fire like this, kind of the same attack like against that. So we're gonna just do one of these numbers. IP port 80. There we go. Okay. Let's see if we got anything. Whoops, wrong button. Okay, so we got a guest computer on this remote random target, and if I were to look at the home directory, you can see there's a mail.txt and a bank.txt, and they contain an MD5 hash of their passwords, which you can use the game's decipher program or a rainbow table of your own to decipher to get their email and bank credentials and then do nefarious activity with that information. So if you don't get a shell object, you can still do stuff with computer and guest that can eventually get you to a shell object. And if you remember Felix, the little file explorer can do the same thing. That's so if you just have a file object, you can still go in here, go into their config folder, and get their mail information or their bank information. Okay, so unfortunately this video got a little bit long, and I do apologize for that. You were probably expecting something a little different, but it definitely got a little long, and we haven't even finished yet. So what I'm going to do is I'm going to make a part 2 where we're going to actually fill out what we do with the results that we get, so that you have a complete program that you can at least get started with, and then fill it in to make it all sorts of cool and way better than anything that I've made. Alright, good luck, and thanks for watching. Like, subscribe, all that, comment, good stuff, because it helps more than you can know. Or maybe you do know, but just like, seriously, help a guy out. Alright, bye.